Next, we'll start with stack. Stack, how it is going to be work. On what basis the stack is going to be store the elements. The technique of last in, first out. Last in, first out. By using that particular technique, it is going to be follow to store the elements. So array list. One second. Yeah, it implements the last in, first out data structure. Whichever the element is going to be entered first into the stack, that will be the element which will comes out last. So here we have push method, which is useful for inserting an element into the push item or object. Used to add an element into the stack. So add method, instead of having the add method, we'll be having the push over here. Instead of having the add method, we will be having push here. Okay. Now pop, we have used to remove an element from the stack. We'll see what are the methods we'll be having with the stack. Each one with an example we'll see. This is a legacy classes. The classes what we have before this Java 1.5, that is will be called as legacy classes. Okay, so we have to import that related package. Now, if you want the first method, what we have here is dot push an item. Is dot push of we are going to be add all the elements. So element from the stack. Stack yes will be displaying here. Stack yes will be displaying here. 1, 2, 3, 4, 5. So by using the add method also, we can able to add. See, this is all common we have. If you want to know the capacity of this first, we'll see capacity of stack S. Capacity stack S. but we have given only 5 elements. As of now, we have given only 5 elements, but it is going to be displayed as 10. If you see the size of the stack, again we'll be having 5 only. Size of stack s, size of stack s dot size. So I can check here 5 only. Size of stack is 5. Size of stack is 5. Okay. Now more than 10. See, the stack S capacity is showing 10. More than 10, we cannot able to store the elements. We can able to store. We'll see that. S dot add 10. S dot add 20. S dot add 30. S dot add 40. S dot add 50. S dot add 50. See, previously we have 5 elements. Previously we have 5 elements. And now if you see here, 6 elements we have. 6 elements we have. So now I'm going to take all these 3 again. I'm going to display the elements of stack S. I'm going to display the elements of stack S. And I'm checking the capacity of stack and size of stack as well. See, when one element has been changed, previously the capacity of S is 10 we have, where we have stored only 5 elements. Now 11th element we have given, the size of the stack has been given as 20. Here also it is going to be grow its size dynamically. Here also it is going to be grow its size dynamically. Returns the current capacity of the vector. Add is also used for inserting the element. Next we'll see. See, I'll create the empty stack first. Stack S1, new stack. Now stack S1 is empty. Stack S1 is empty. Stack S1. Stack S1. And if I'm checking the size of it and the capacity of this, you will come to know the capacity will be 10, and the size is 0. Capacity is 10, size is 0, because we didn't add any elements as of now. As we didn't add any elements, it is going to be give this. Any doubt in this? What is the capacity? What is the size difference? By default, it is having the size as 10. Going forward, if we require, we can, as many number of elements we are adding, it is going to be added. As any number of elements we are adding, it is going to be get added.
Sir, how to know capacity, sir?
Huh?
How to know the capacity, sir?
That we will suggest what is the capacity we can display, but we cannot able to set the capacity. See, we have s1 dot set the size we have. Set size we have. Let's suppose I'll be giving the size as 5. Now, if I'm taking the size of this, sorry, yes, size I have given, right? S1 size I have given. Now we have 0. Now we have 0. So after setting the size 5, we are getting the size as 5. See here, size is 0. We didn't add any elements into it. We are assigning the size as 5. Assigning the size as 5. Now, size is 5, it will display. Size is 5. Size is 5. As we assign the size, it is going to be displayed. The size is 5. Now, after adding 6 elements into it, let the size is going to be 5 only. We'll check. S1 dot add of 11. S1 dot add 22. Let me check this again. Will be getting 11. Dynamically it is going to be increased. Here we have assigned the size of the stack is 5. When we are storing 6th element, the size is going to be increases. 5 plus 6. If I'm adding some more elements, S1 dot add of 77, S1 dot add of 88. So 2 elements I have added here. After adding these 2 elements, if I'm checking the size, we are going to be get plus 2. 13 we are getting the size. After assigning the size, it is going to be increases. After assigning the size, it is going to be increases. Right. So now, we'll be displaying these elements. What is there in the stack S1? See, initially we have given the size as 5. We have set the size as 5, but we didn't add any elements, right? In that particular case, it is going to be store all the values. As the size we have given here, if we didn't store any values, by default, it is going to be considered as null. See, all the values, all elements till size 5 will store as null in the stack. It will store like null in the stack. Okay, it will store like null in the stack. See, pop operation. Pop operation. It is going to remove the last element by default. So by default, it is going to be remove 88. By default, it is going to be remove 88. Will be getting 80. 88 is getting removed. Now again, if I am applying this pop function, so whatever the element entering into the stack will be enters first, that element will comes out last. That element will comes out last. Now 77 will get removed. 77 has been removed here, from here to here. Any doubt in this? Any doubt? Push pop. Remaining index of last index of add all. Then we have remove all. All these things is common. Like array list we have discussed, linked list also we have discussed. The different things will be getting here in the stack is these methods. These methods. Any doubt as of now? If any doubt, you can ask. Any doubt?
No, sir.
Next we have vector. Vector is also dynamic array which is used to store the data elements which will works similar to the array list. Which will work similar to the array list. See that vector. Just a minute. Vector B new vector. Here also it is going to be follow array list as a data structure for storing, and it is going to be um, see here v dot same methods will be there. Same methods will be there. Only the thing is the purpose we are using is different. Based on that, we have to get it. See here. So most of the time, we are not using this linked list, array list, maps, hash map. These things we are going to be discussed. We are going to be used most of the time based on the features available. So if we want duplicate elements to be added, then we are going to be use either linked list or array list. So that too, if we want to add in both forward direction and as well as backward direction, we are going to use the linked list, or otherwise we are going to be use a linked array list. So like that. Next we are going with the next interface. Set interface has set. There will not have um, it will not allow duplicate elements. It should not accept the duplicate innocence. We are going to be use any of the class of set. What are the different features that also we will discuss. So see here. Also by using the iterator, we can able to display each and every element. These are the elements of iterator. Iterator object. See, while iterator dot has next dot has next. It is having the element. We are going to be displayed. We are going to be displayed. Sorry. Next. Yeah. So individual elements it is displaying. Individual elements of this vector it is displaying. Here also, if you want to get, we'll do that. Iterator iter s1 dot iterator while itr dot has next will be displaying this itr dot next. Okay, individual elements it is displaying here. From here, if you see, we are getting the individual elements. So like this, we can use. Any doubt as of now?
No, sir.